All right, so this is our empirical formula lab video. I have my microphone fixed, had some technical difficulties last night, so we got those situated. So what I'm going to do is just go through very quickly the student data sheet and what you need to make sure you have written down, especially for my remote students, so that you can then take this data and put it in and use that data to answer the analysis questions, even though you weren't actually present for the video. And we are working on getting our Pivot Interactive set up so that you will be able to do videos at home, do labs at home virtually. Okay, so here is the student data sheet. And this is in our Schoology day 2, I think, for Unit 1. So first off, you're going to write a balanced chemical equation to represent the reaction between magnesium and hydrochloric acid. So magnesium is Mg plus the HCl gives MgCl2. It's MgCl2 because magnesium has a +2 charge, chlorine has a -1 charge. So to get those charges to balance out, I need 2 chlorines. Well, that also means that I need to put a 2 in front of this HCl so that my reaction is balanced. Okay. It says calculate the milliliters of 3 molar hydrochloric acid needed to completely consume the magnesium. Verify this calculation with your teacher before proceeding to the next step. Okay, well, we are not using 3 molar, so we are not going to do that part of the lab. We used 1 molar, and so we're just going to kind of leave that one for simplicity's sake. All right, so if you come down here, I'm just going to use some sample data that I have from my teacher's edition. With this lab and most labs, there isn't necessarily a right or wrong, what you're number-wise, what you're supposed to get, what you're not supposed to get. We are basically just going to be looking at what you got, and we look at our procedures, okay? Because, things always can't always go wrong in lab, and we want to make sure that we do allow for that because sometimes it's not anybody's fault. All right, so your numbers, if you did this in lab, your numbers are not going to be like mine, and that's okay. If you did not, we're just going to take one of our sets of sample data and we're going to use that as your numbers. So to start with, we are going to take the mass of our beaker as being 50.1582. Okay, so that's what's going to go in there, and that's just the mass of just the beaker. The mass of the beaker and the strip of magnesium that we put in it is 50.3070, and that is a 3. Okay, so we're going to subtract those two numbers to get the mass of the magnesium. Okay, so mass of magnesium is going to be those two numbers subtracted. So 50.3070 minus 50.1582. If we subtract those two things, let's see. That gives us our mass of magnesium as being 0.1488 grams of magnesium. So that's the amount of magnesium we had to start with, right? So the mass of magnesium that was consumed, so we're going to take that magnesium out of the beaker, we're going to weigh it again, and the mass of the magnesium after the reaction is 0.0819. So this is our before, this is our after. If we subtract those two things, that will tell us how much magnesium is consumed in the reaction, how much got used up to make the magnesium chloride. which gives us 0.0669 grams of magnesium. Okay, so that is the amount that gets consumed. Okay, the mass of the beaker and the magnesium chloride after the first, second, and third heatings, that's just when we heated it up to drive off all the water. We found that the magnesium plus the beaker is 50.4207. And we're not going to worry about those two. Okay. All right. So that's the magnesium of the mass of the beaker and the magnesium chloride. Then to find the mass of the magnesium chloride produced in the reaction, I'm going to subtract this number from the mass of my beaker. So 50.4207 minus 50.1582 gives us 0.2625 grams of magnesium chloride. So I think I wrote those numbers backwards, 2526. Sorry, I wrote those backwards there. That's our mass of the magnesium chloride that's produced. So now to find the amount of chloride ion in our magnesium chloride, what we're going to do is we're going to subtract the 0.2526, which is the magnesium chloride. We're going to subtract that from the mass of the magnesium that was consumed, 0.0669. Oops, that's magnesium. And that will give us the amount of chloride. Hang on. There we go. Okay, so when we subtract those two things, that's going to give us 0.1857. And that's our grams of chloride. So we're going to put that in here, 0.1857. Okay, so let me erase all this work. And then we're going to go down and start working on some of the other analysis questions afterwards. So the first one, after completing the graphical analysis of the class data, okay, we're going to skip that for now because we have to have our class data in order to do that. And we have not gotten that done yet. Okay, so we're going to skip that portion for now. So we're going to go on down to number 1 there, and we're going to start calculating our moles of magnesium, and our moles of chlorine, and determining our empirical formula. Okay, so let's scroll this up. There we go. Finish erasing this first. All right, so the way we're going to find the moles of magnesium that was consumed is we're just going to take our grams of magnesium that was in the table, and we are going to divide it by the atomic mass of magnesium. Okay, so for the magnesium consumed was 0.0669. And then we're going to multiply that by the atomic mass of magnesium, which is 24.3 grams in 1 mole. So when we do that and divide those numbers out, we get 0.00275. moles. Okay, and then we're going to do the same thing with the chloride to calculate the moles of chloride. So we'll do that on this side. So our amount of chloride was 0.1956, and we are going to turn that into moles by multiplying or dividing by the atomic mass of chloride, which is the mass in 1 mole. Always. The atomic mass is always the mass in 1 mole. So, I'm sorry, that was the wrong number in there. Let me erase that. That 8 is not there, and that 6 is not there. That should be 857. So 0.857 divided by 35.45 is 0.00524 moles of chloride. Okay, and then to determine the mole ratio, all I'm going to do is I'm going to take the smallest of those two numbers and divide it into both numbers. Okay, so the smallest is going to be this one. So I'm going to take this number here and I'm going to divide it into both of these mole numbers. So 0.00275 divided by 0.00275. We divide that out as 1. And then our other one is going to be 0.00524 divided by 0.00275. So we divide that. We get 1.9. So our ratio is 1 to 1.9, which is pretty much 1 to 2. So our mole ratio is 1 to 2. Okay. Then we are supposed to calculate our percent error. So the formula for calculating percent error all the time is the measured value minus the true value divided by the true value. And then we multiply that by 100. Okay, so our measured value was 2. Our moles of chlorine was 2. The true value, according to our our balanced equation, is 2. And we divide that by our true value, and then we multiply by 100. So that means we have a 0%. Oh, I'm sorry. Wait a minute. Back up. Our measured value is 1.9. So 1.9 minus 2 divided by 2 times 100 is 4.5%. And it's the absolute value of that. So we can just, did it again. So we can just disregard that negative sign there. So that's going to be 4.8%, which is a really good percent error. Of course, the smaller the number, the better when it comes to percent error. And what is the molar mass of magnesium chloride? The molar mass is the mass in 1 mole. So what I'm going to do is add up the mass of the magnesium that's there, and then I'm going to add up the mass of the chlorine that's in there, and that becomes our molar mass. So we have 1 magnesium atom and 2 chlorine atoms. Okay, so I'm going to look the mass up on the periodic table, and the mass of magnesium is 24.3. And I have 2 chlorines, so that's going to be 2 times 35.45. And that will be should be 95.2 grams in 1 mole. Grams per mole. Okay, so now let's take a look at the second page. We're just going to do a few of these. We're not going to do all of them because, there we go. Because some of them are just going to be problems not necessarily related to the lab. They're just learning how to work these problems out. So number 6 is what is the percent composition of the magnesium and the chlorine in magnesium chloride. Okay, so for doing that, I'm going to take the mass of each of those elements, and I'm going to divide by the total mass of the compound. Okay, so the mass of each element and then the total mass of the compound. So if we go back up, so 24.31, that's the mass of magnesium, divided by the total mass of this compound, which is the molar mass of it. It's 95.2. And then I multiply by 100 to turn that into a percent. So that means that I have 25.53% magnesium. And then for the chloride that's in there, I'm going to take my chloride ion, and there's 2 of them, so 35.45 times 2, because I have 2 chlorines in there. And I'm going to divide that by my 95.2. That's the molar mass. I'm going to multiply by 100. And that's going to give me 74.47% chlorine. Okay. So on number 7, it says if you're given 100 grams of magnesium chloride, explain how the empirical formula of the compound can be determined from the percent composition data. So if you're not told the molar mass, or if you're not told how much you have, what you can do is base that off of 100. And then knowing your percent composition, you can work backwards to find the empirical formula. So for example, if I have 100 grams, I can then say that I have 25.53 grams of magnesium, and I have 74.47 grams of chlorine, or the chloride. So to find the empirical formula, what I can do is just take those numbers and divide them to make my ratio. Okay, so what I can do to get those into the empirical formula is when I divide them, I can take my percent compositions, since this is based on 100 grams, sorry. I can take my percent compositions, and then I turn those numbers into moles and then find my mole ratio, which is basically your empirical formula. Okay, so to divide 25.43 by the molar mass of magnesium, because that's the grams in 1 mole, that will then give me a molar mass of 25.53 divided by 24.3 is 1.05. And then 74.47 divided by chlorine is 35.45 times 2, 70.9. No, I'm sorry, that's wrong. 74.45 divided by 35.45 is 2.1. So both of those are pretty close and round to that 1 to 2 ratio. Okay, so to go from percent composition to empirical formula, if you're given 100 grams, all we need to do is drop off the percent sign. That becomes our grams, and then we turn grams into moles. Okay, whenever we're changing and trying to find the empirical formula, we have to change grams to moles. Okay, grams of each element that's in the compound to moles, and then we divide the smallest number into both of those mole numbers, and that will then give us our mole ratio. Okay, all right. Okay, so if we look at number 9, we are removing water. So why do you have to heat it at least twice instead of heating it just one long time? Why is it better to heat it 2 shorter times? You can just think about that one and use your best judgment as to why that you think that would be better. Number 10, you can answer that one on your own as well. Number 11, mass percent of a compound is an intensive property. Provide evidence from this experiment to confirm or deny the statement. So mass percents are intensive properties. That means I'm not going to go into that. So you provide some evidence to confirm or deny that. That's intensive properties is in your notes. Number 12 is calculate an empirical formula from a percent composition, just like we did in number 7. So you're going to do the same thing you did in number 7. So I'm going to let you work that one on your own and see if you can get that one correct as a practice problem. Magnesium is a metal. Describe the metal atoms in terms of the number of protons and electrons, and identify and describe the bond between the atoms of the solid. So again, we're talking about bonding with those. As far as describing the magnesium atom, remember that the atomic number on a periodic table is the number of protons, which is also the number of electrons for a neutral atom. And then magnesium, because it's in the second column of the periodic table, it can lose those 2 electrons, those 2 outermost electrons, very easily and become positively charged. So that's also just kind of a review question. Review as in back to last year. All right. Let's do this. Number 14. Let's go ahead and answer number 14. And then we are going to skip 15 through, let's skip 15 through 18. Okay. So in 14, it's asking us, describe the magnesium and the reactant to the magnesium in the product in terms of the number of protons and electrons. So the magnesium metal versus magnesium chloride. How many protons, how many electrons does it have? Magnesium metal is going to be neutral. So it's going to have the same number of protons as it does electrons, which is its atomic number. Magnesium in the magnesium chloride has a positive 2 charge. It has lost 2 electrons, which is why it can then react with the chlorine. And it's lost those 2 electrons to chlorine. So the magnesium now has a positive charge and the chlorine has a negative charge. Things that gain electrons are reduced. Things that lose electrons are oxidized. So the magnesium is losing 2 electrons, which means it is oxidized, and the chlorine is gaining 2 electrons, 1 electron for each chlorine. Okay, all right, let's look then here. All right, so you have a lab situation where you are given a mass. You are told that he heats it to drive off the water. First heating, second heating, third heating. And William is told by his teacher that the molar mass of anhydrous magnesium chloride, anhydrous just means there's no more water in it. So you're going to go through here and fill these out. And it's basically the same reaction again. just have different numbers for masses. So you're going to tell me from that paragraph, what was the mass of the hydrate that he started with, how much anhydrous salt is left in terms of grams and then in terms of moles, and then determine how much water was driven off. So the amount of water driven off would be the difference between the two masses, the mass to start with and the mass to end with, which should be the amount of water that was driven off in those two situations. So in grams and in terms of moles. Then you are to write down the mole ratio as a decimal number. That's just the raw number for determining the moles of the salt and the moles of the water. And then you make a mole ratio out of those things by rounding them to whole numbers. Then determine, based on this mole ratio, you would then determine what the formula of that hydrate is. And then you can determine the percent of water that's in there. And then we'll skip H, naming the hydrate. Okay. Okay, we are not going to do the elaborate section of this lab at this time. Okay. So once you get done with the scenario with William, then you will have completed this lab and you can just submit it. Okay. All right. I think that's it. So have a great night.